Wastewater treatment operations face increasing pressure as regulatory agencies enforce stricter nutrient limits. And at the same time, rising operational costs make efficient nutrient management essential for both municipal and industrial facilities. Hello, everyone, and welcome. I'm Miles Skoda, and this is the wateronline.com virtual event series. And today we're talking next gen water quality monitoring, reliable data, better decisions. Joining me for this presentation are industry experts from Hach, Mike Feldman and Amy Pollock, and our moderator, Global Media Manager, Stacy Flax. And together, our speakers are going to look at two case studies, including a municipal plant using online total phosphorus analysis to prevent permit violations, and an industrial beverage facility saving $350,000 annually with automated total nitrogen monitoring. They're also going to look at how advanced analyzers provide early warnings, enable rapid operational response, and streamline compliance. We are going to be holding a Q&A session as well following this presentation. Please feel free to submit questions as we go along. We'll get to as many as possible during that Q&A, and any that we don't get to, I'm going to pass along to the team here for potential follow-up after the event. And then just a bit of housekeeping. If you run into any issues today, please try refreshing your browser first. If your problem persists, you can submit a question through that Q&A, and I'll be here to help get you back on track. And then finally, this event will be available on demand, usually within a day, often much less. You'll get an email with a link to it, or you can just use the same link that you used today. So with that said, let me turn it over to Stacy to tell us a little more about everything today and our speakers and get us started. Stacy?
Thanks, Miles. Welcome, everyone, and thank you for joining our live webinar. As Miles said, my name is Stacy Flax, and I'm the Global Media Manager here at Hach. I'm excited to kick off today's session, the next generation of water quality monitoring. But before we begin today, let's ground ourselves and why we're all here. For more than 80 years, Hach has been committed to one mission: empowering water professionals with the tools, technology, and expertise needed to deliver safe, reliable water to communities. From our earliest innovations in grid to today's advanced online solutions, Hach supports all customers all over the world, helping them reduce downtime, simplify operations, and make confident, compliant decisions. The depth of expertise and our dedication to the people who operate water systems every day is what brings us together. Today, we're going to be hearing from two exceptional Hach experts, Amy Pollock and Michael Feldman, as they share how next generation water quality monitoring supports the regulatory compliance and strengthens process control in both municipal and industrial applications. And before we go any further, I'd like to give a special shout out to Bradley Connectus for all of the support in putting this webinar together. We truly appreciate the partnership behind the scenes that makes sessions like this possible. So going into one of our first presenter, Amy Pollock. She is the Senior Sales Development Manager here at Hach. She joined Hach in 2009 as a Regional Sales Manager supporting Vermont, New Hampshire, and Maine before transitioning to her current national role supporting regional sales managers across North America. Her background reflects deep technical and operational expertise. She has a bachelor's in environmental science from Rutgers, master's in environmental studies from UMass Lowell, 10 years as a project manager in environmental engineering consulting, a licensed Massachusetts Grade 2 industrial wastewater treatment plant operator, serves on multiple water industry committees, and has nearly 20 years serving on her town's conservation commission, protecting local water resources. Michael is next. Michael Feldman, Senior Sales Development Manager at Hach. Mike has been part of Hach since 2005, beginning at our headquarters in Loveland, Colorado, before spending more than a decade in the field as a regional sales manager in Albany, New York. He is also a member of Hach's Global Subject Matter Expert Team, a select group of about 30 specialists across the organization. Since 2014, his focus has centered on the power, beverage, and pharmaceutical, semiconductor, and ultra-pure water markets, bringing extensive insight into high-precision, high-stakes applications. Mike holds a BS in chemical engineering from the University of Michigan. Go Blue! All right. Both Amy and Mike are true water champions, bringing decades of experience and a genuine passion for supporting water professionals. All right. Today, we've got a couple of notes that this session is meant to be educational. Our goal is to share helpful insights and not endorse any specific technologies or processes. You're welcome to share this information internally as long as Hach is credited as the source. Our learning objectives today are threefold. Explore best practices for integrating nutrient analysis into existing and evolving workflows, and gain practical strategies to maintain process consistency. 2, how the municipal and industrial facilities leverage actionable data from online nutrient analyzers to stay in compliance, reduce costs, and improve treatment efficiency. And 3, how validated technology for nutrient analysis can deliver a measurable return on investment and peace of mind at your facility. Since our founding in 1933, Hach has led the industry in developing innovative solutions to help our customers analyze their water more efficiently and effectively. Our vision is to make water analysis better, faster, simpler, greener, and more informative. We offer solutions for laboratory, portable, and process water analysis, including equipment, chemistry, and support. We serve a broad range of applications, including wastewater, drinking water, and industrial applications. Today's cases will focus on muni and industrial wastewater. We have a complete listing of EPA approved, accepted, and equivalent methods, some of which we have created for compliance monitoring on our website. You can navigate there directly by typing hach.com backslash, I almost said backsplash. I'm thinking about like summertime here. EPA into your web browser. So that's hach.com/EPA. All right. We do have a global reach in both manufacturing and engineering, and we also have direct sales, service, and distribution networks that you can leverage for any support that you need. Our global headquarters is in Loveland, Colorado, and we are wholly owned subsidiary of the Veralto Corporation, a global leader in essential technology solutions, which safeguards the world's most vital resources, including clean water and safe food. To support our learning objectives, we'll start with a discussion of laboratory sampling techniques, reviewing the benefits and drawbacks of offline methods. Then we'll move into our first case study in which a municipal plant uses online total phosphorus analysis to prevent permit violations. This is going to be followed by a second case study in which an industrial beverage facility realizes significant annualized operating cost reduction through the adoption of automated total nitrogen monitoring of a waste stream. Both cases use a common analysis platform, which we will cover in the next section before moving to the question and answer portion of the presentation. All right, I'm going to pass it over to Amy to kick us off.
Thanks, Stacy. Lab monitoring can come from a few different places. Some plants rely on a third-party commercial lab. Others use a central lab run by the county or the utility, and some do everything in-house. No matter where it's done, lab work is part of the day-to-day reality in wastewater and in industrial treatment. We collect lab samples for a lot of reasons. Daily rounds help us see how the process is shifting. Sometimes we need lab results before we make changes to chemical feed, wasting rates, or pump recirculation. And of course, a lot of our sampling is simply driven by permits and compliance requirements. Lab analysis still plays a key role in keeping a plant running well. Those periodic checks tell us whether the process is behaving the way it should. Lab data also lets us confirm that our online instruments are working correctly and giving us trustworthy readings. There are parameters where lab testing is perfectly fine, things that don't need constant control, or parameters where automated analyzers just don't exist yet. In those cases, the lab is the only option we have. But there are some downsides. Lab work takes time, trained staff, and careful technique. Outside labs can get expensive, and the turnaround time is often 2 weeks or more. Results can vary based on how the sample was collected, how long it sat before testing, and even who ran the test. That's especially true for nutrients like phosphorus, ammonia, and nitrogen that we'll talk about today. Those samples are biologically active. The numbers can change between the plant and the lab if they're not preserved or tested right away. And because most lab work is based on grab or composite samples, it doesn't always catch a problem soon enough to help us prevent an upset. Even total phosphorus or total nitrogen in the lab requires a skilled tech and can take up to an hour or more versus a process analyzer, which give us answers in half the time. So while lab analysis is essential, it's important to understand its limitations and pair it with the right online instrumentation strategy. The two together give operators the information they need to stay ahead of the process instead of chasing it. Online monitoring gives us visibility during the hours when lab work isn't happening, between shifts overnight, weekends, or even upcoming holidays. And it provides real peace of mind about what's happening in the process. Online analyzers also reduce chemical exposure. Instead of driving samples across the plant or handling reagents repeatedly, the analyzer does the work automatically and safely at the point of measurement. Another advantage is flexibility. We can install online analyzers at the exact point in the process where the data matters most. Maybe that's the primary, secondary, final effluent, industrial discharge, blending points, or even EQ tank, wherever it's needed. Online units can also run grab samples when lab staff aren't available, which is especially helpful on weekends or off-shift hours. And instead of getting one result a day, online analyzers can generate 48 results a day or even more, depending on the parameter. Dilution can be automated as well. So you eliminate those math errors, calculation mistakes, and cross-contamination issues that can happen with manual dilution. Overall, online instrumentation provides a continuous, complete view of what's happening in the process. Instead of relying on once a day or once a shift grab samples, we can actually see trends as they develop. It detects trends, spikes, and upsets that grab samples simply miss. With real-time alerts, operators get true early warning indicators and can make proactive decisions instead of reacting after the fact. It also improves data consistency and accuracy because we're not dealing with those sampling or handling errors. This frees staff from routine testing so they can focus on higher value operational work. And ultimately, continuous monitoring helps optimize the process, maintain compliance, and deliver reliable data. This graphic shows why online monitoring is so critical for catching problems early. Imagine a process upset happens at 5:32 p.m. with a spike of phosphorus or possibly nitrogen. With online instrumentation, the problem is detected in real time here at 5:40 p.m., just minutes later. In contrast, if you rely on grab sampling and lab testing, you might not even know about the issue until 7 p.m. or maybe the next morning. That's a delay of over an hour and a half or a full 24 hours. That can mean the difference between a quick chemical or pump adjustment and a costly process failure or permit violation. Think of it like a smoke alarm in your home. If there's a fire, the alarm goes off right away so you can act fast and respond. Waiting on lab results is like only checking for smoke once a day. It's way too late and the damage is already done. That delay can lead to bigger problems, more downtime, and costly violations, or maybe even bad press. Online monitoring gives you real-time alerts so you can fix issues before they get out of hand. It moves your plant from constantly reacting to problems to managing things proactively and confidently. With some of the lowest detection limits on the market, we take the same form, fit, and function of this analyzer shell and we combine that with internal components for unique parameter analysis. The easy phosphorus analyzer on the screen has the SC4500 controller built in, which is the industry standard for ease of use and intuitive menus. The instrument menus are designed for operators and use simple to understand language and steps you through things like configuration, setting options, communication outputs. Maintenance tasks are understand easy to use, step-by-step instructions. Warnings and alarms with clear instructions help you solve quickly and get the instrument back up and running. With that, you still have Hach's standout online technical support and in-field factory-trained service technicians for on-site preventative maintenance repairs and staff training. Now, let's take a look at a plant who implemented this easy online phosphorus analyzer. The Marble Wastewater Treatment Plant is a sophisticated facility with tertiary sand treatment designed to manage a daily average flow of 2.89 million gallons a day. It serves the western part of Marlborough and an adjacent town in an intermunicipal agreement. Operating under a National Pollution Discharge Elimination System permit, or commonly known as NPDES, it's issued by the EPA and the state DEP. The facility runs on a single shift and does not have overnight staff, which makes real-time monitoring crucial. The plant has faced challenges due to industrial discharges and seasonal variations in phosphorus levels, driving them to investigate advanced monitoring solutions to maintain compliance and operational efficiency. Here we're looking at the NIPD's permit summary outlining strict phosphorus discharge limits that change based on the time of year and season. The summer monthly average of 0.1 milligram per liter with a daily max of 0.2, and then the winter average daily maximum of up to 1 milligram per liter. Several years ago, the plant experienced 4 permit violations, highlighting the difficulty of maintaining compliance amid industrial discharges and seasonal spikes. These violations were often triggered by unexpected super hits from potential industrial cleaning processes and other manufacturing plants in town, which caused foaming in primary treatment stages. Prior to the installation of the online phosphorus analyzer, the plant was running blind and behind, with once-a-day, 24-hour composite samples with results not available till late to mid-morning. Chemical dosing was set it and forget it, or overdosing to catch up when hit with high phosphorus loads at the influent. After the installation of the online phosphorus unit, the EZ Series analyzer provided early warnings of phosphorus spikes, allowing operators to take proactive action such as adjusting where and how much to dose that ferric chloride, along with adjustment of wasting rates to mitigate the impact. Here's a photograph of the actual installation of the EZ Series 2-stream phosphorus analyzer installed in the final effluent UV building. It plays a critical role in real-time monitoring of the phosphorus levels. It samples hourly from pre and post sand filters, analyzing for both total phosphorus and orthophosphate. This dual-stream capability allows operators to detect anomalies and respond promptly. For example, a spike of 0.25 milligrams per liter, twice as what their permit is, was identified immediately, enabling timely intervention. The analyzer's data trends help operators adjust waste flows and chemical dosing, improving treatment efficiency and preventing permit violations. This system provides a comprehensive view of treatment performance, especially in their tertiary stages where reactive phosphorus and ammonia are removed. Seasonal changes, particularly in spring, bring challenges due to increased use of phosphorus-based cleaning products in local industries. These chemicals enter the influent stream, causing spikes up to 2 milligrams per liter or more, creating foaming issues in the primary, secondary treatment stages downstream. The EZ Series analyzer enables the operators now to manually dose that ferric chloride and adjust the secondary clarifier operations to manage these spikes. By turning up their wasting rates and pressing out more phosphorus, the plant maintains compliance 24/7. The analyzer is integrated with their SCADA systems, allowing for faster response compared to their traditional 24-hour composite sampling, enhancing the operational agility and reducing chemical usage, along with a better night's sleep, according to the chief operator. The lab at the plant utilizes the Hach visible spectrometer with a dry thermostat reactor for digestion on total chemistry, plus the TNT Plus for accurate phosphorus testing, among other nutrients. These tools offer multiple ranges, with detection limits as low as 0.01 milligrams per liter and as high as 30 milligrams per liter of phosphorus as P, with results matching plus or minus 0.01 milligrams per liter of the online unit. The lab chemist describes the equipment as convenient and user-friendly. For maintenance, the plant partners with Hach Service Division, providing quarterly visits by factory-trained technicians for online instrumentation that includes the EZ Total Phosphorus Analyzer, as well as their lab instruments. The service plan includes all parts, labor, and travel, ensuring reliability and peace of mind. Certified reports are issued after each visit, and the technicians are praised for their professionalism and expertise. Now, let's hear live from the chief operator, Scott.
Hi, Scott. Thanks for joining me today. What's most important and critical to you in running the wastewater treatment plant?
I believe that the most critical part of running this plant is my effluent quality. That's right at the top of my list.
Okay, yeah, and I can imagine it's challenging with a smaller facility, a smaller staff. How do you manage, unplanned events, changes in your influent, unexpected spikes maybe on any nutrients like phosphorus, ammonia? I mean, what does that look like for you?
My ammonia, we'll start right there with ammonia. There are a lot of things that I am permitted for, and ammonia being one of them isn't really a big issue with me here. My biggest issue is a phosphorus issue. I have 19 SIUs coming into this facility outside of my control. I have an IPP coordinator who handles all of that and monitors their reporting. And my phosphorus issue is a very important aspect of what I do here. But he went ahead and purchased that EZ analyzer, and that's been a big game changer here for me, especially with my upstream SIUs, a few of which are food grade SIUs. They put out a high phosphorus, especially when they're doing a lot of their cleaning. And I've got a lot of pharmaceuticals upstream for me. And knowing that those phosphorus numbers are coming in high, like I said, that EZ analyzer, which I use, in fact, I'm looking at it right now on my skater in front of me, is an important tool because it allows me to get that phosphorus knocked down a little earlier in the process at my primary treatment.
So have you been able to calculate or see, is it either energy or maybe chemical cost or even time, maybe resource reallocation? What have been the benefits with that online instrumentation?
It's been more chemical. I dose ferric chloride to offset the phosphorus going into my secondary system before it enters the sand filtration system here at this facility. And knowing what's coming in and being able to attack it in my secondary process before it goes into that filtration system is a big help. So I'm able by using SCADA to increase or decrease the dosing according to what I see coming in as far as phosphorus in my secondary treatment using my EZ analyzer, which is directly linked with my SCADA system. Using this system has increased because I'm able to dose. We also dose ferric into that sand filtration system. It allows me not to clog up that system with a lot of chemical, which will it just equates into lots of maintenance issues as far as more cleanings, just a lot more labor-intensive processes going on here at the plant, and that allows me to kind of set it and forget it.
And how do you utilize the lab results? So that's in your visible spectrometer. You're doing grab sample analysis on 24-hour composites?
Correct. We're using all the TNT Hach systems with that also. In fact, when I first took this position, I implemented the purchase of all those TNT, all that TNT equipment in our lab, taking away, just kind of pretty much eliminating the secondary, sending stuff out to a secondary lab for a lot of analysis that we could have been doing in-house all the time. It's been a really big help, and I've, just in the first year, I think I saved somewhere close to $10,000 in lab costs just using the DR30. I think it's a 3900, I believe, and 3900 and all the TNT sampling that we do now. Now my lab team is really proficient in using that system, and they're pretty good at it. And especially I kind of do a comparison with my phosphorus numbers, and I'm constantly trying to prove the EZ analyzer wrong. And when you're coming up between 0.01 or a 0.02 or a dead even on a composite sample to an hourly grab, which what happens in my EZ, that's pretty close. that's pretty accurate. So it gives me a lot of faith and hope knowing that that machine is running in tip-top shape and giving me the numbers that I need. I have remote access to the facility through SCADA and the city website, so I can monitor that system and all the systems throughout the plant on SCADA remotely. Yep.
I really want to thank you for your time today, and I look forward to seeing you again in the future.
Thanks for having me. It was great.
Thank you.
Now I'd like to pass the mic to my colleague, Mike Feldman.
Great discussion, Amy. Just another testimony to why we love what we do and going out and helping and understanding our customers' challenges and working with them to help solve or mitigate those. So great job. Thank you. So we're going to kind of jump over the fence here today, now here in this section, and talk about the other major nutrient, nitrogen. In nitrogen in an industrial setting. So moving over from the muni side to industry, we cover all corners of the world here, as we discussed earlier. In this case, we're going to talk about reverse osmosis and some of the impact that it has on some of these sites. Just a little background. We have over 10,000 bottling plants within the North America using multiple stage reverse osmosis, but it's not always there too. I work with a lot of industrial sites, whether it's semiconductor or pharma, hospitals, almost every location that we go to that needs good, clean water for either boilers or other parts of their processes are using these tools, which are very effective. Hach has spent a lot of time monitoring on the front end, dechlorination, and doing a lot of work on that end with the lab and process. But one thing that's really popped up more and more is the needs that arise on the reject water, brine, or what they call concentrate. Two-stage ROs can concentrate water upwards of 98%. So that means we're sending really good, clean, pure water out to be used, and then we're rejecting a lot of water that has built up dissolved solids and other compounds. So in this case, what we find even in the industry is that there are a lot of uses for that reject water. There's a lot of initiatives industrially for better water sustainment and using that water in other places and not just putting it down the drain, or you might have limitations in current waste treatment processes where they can't handle the loading or what might be coming down. So there's a hope that you can directly discharge these safely back into the environment. But one thing people don't think about too is that as things come in, if it's a small change in the inlet, it becomes a big change on the outlet. Concentrated nitrogen slugs and loading can be challenging for any big municipality, but especially even for the smaller package plants that are working there. And that can cause issues in exceeding permit limits or other process limits that they might be using in other reject water uses. So in this case, where is that nitrogen coming from in drinking water? It could be a couple sources. It could be agricultural. So if you're in a rural area, as in the case that this case study was presented, we could have agricultural nutrients that when it rains, it comes into the reservoirs or into the rivers and the source water. You could have other nutrients and other things coming in. It could be snow melts. Even in the winter, we sometimes see salt concentrations jump up when people are de-icing. So a lot of things coming down the loop that you have to be aware of when utilizing these tools. Some cities even use chlorinamation, where you're reducing your disinfectant byproduct by adding nitrogen-based compounds to stabilize that disinfection. And again, that could be another big source there for those nitrogen. So in the case of this beverage plant that we were working with, they were taking around 300,000 gallons a day of city water. They were running it through an RO system. They had recently upgraded to a really nice two-stage RO system where they were sending about 200,000 gallons to the beverage production. So if you follow here up on the top, they're sending that to production. They were using that to make sodas and seltzers and other beverages, bottled water. and they had an on-site treatment system. So they were using a DAF, which is a dissolved air flotation system, and also an MBR, mixed back reactor, where they were cleaning up the water, separating some of that really high concentrated sludge out, and then sending it to a small public works that could handle all of the rest of that stream. The hope was that here, if you follow down below the RO, that the additional 100,000 gallons that was being concentrated would be able to send directly to the environment. And what they found was that seasonally there were some changes, and in times of the day, or if their production needs to change and their flows were improving, that they were exceeding their limits or pushing the limit, and that made them nervous. They wanted to protect the environment. They wanted to do the right thing, as well as the financial impact that can happen if you have a misstep. So they had a calamity tank, what they have on the site, where they could basically take about a day's worth of side stream or reject water and collect it. But again, limiting their production potentially at times, they would have to get that transported out daily, and that would accrue a lot of cost. So our local rep, who works with them quite a bit in the lab for the waste treatment, as well as some of the treatment processes already, and had worked with them in quality assurance, was brought in to kind of understand the challenge and then see if we could present a solution that would help. And fortunately, we had the Easy Total Nitrogen Analyzer here to help monitor that and understand when they could safely discharge and when they could divert to the calamity tank when there would be increases in their source water. The field service partnership that Hach offers with our Hach employees here to help support them through startup and everything else was also critical. You know, they're very lean, like a lot of industry, and so there was some additional help that they needed here to make sure that we could support and give them reliable information. So kind of to review here the site challenges, they had installed a reverse osmosis system. They needed that for their production lines. They were caught off guard with some agricultural runoff and other seasonal spikes that were happening within their source water that were causing their reject water to hit the limit. Their wastewater reject management, the way that their first countermeasure was just a haul. So that was costing them about $1,200 a day to ship it to a local facility several miles away and get that processed independently. Huge impact they weren't budgeted for, that was causing a lot of stress. They had the few surprises early on where they had risk violating or had violations that caused fines that were anywhere between $30,000 and $50,000. And obviously they didn't want the negative public relation impact on that. They were very conscious of the community around them. They really wanted to meet the 10 ppm total nitrogen limit that they were given, and had a lot of challenges doing it. So they really bit the bullet and did that. So once they approached us, we were able to understand their situation, what did they have in their infrastructure, and present some tools that would help them in that decision-making process. If you look here on the left, this is the actual installation of the instrument. This was our first generation Easy Analyzer. I would point out here in the middle, it's a little bit hard to see from this zoom in, but you can see here where I highlighted, there's a very complex glassware that causes, where it needs cooling water, we're basically cooking the samples. So most of your digested chemistries, phosphorus, metals, aluminum, whatever it might be, we have to basically cook that sample and bring it into a dissolved state where then we can measure it colorimetrically. So in this case, we needed cooling water so that we don't evaporate out what we were boiling in, and be able to present good, reliable data about every 30 minutes. One other interesting fact here too was that the other thing that wasn't accounted for were the additional dissolved salts that were being concentrated in the reject water. It did present some scaling and some buildup within the vessel. We were able to introduce an acid cleaning cycle that did a great job of cleaning that up so that there was no real regular maintenance in this process after we had discovered that it was showing up. So really good situation. And again, tied into all of our goals here, to get this analyzer in, allow them to see the data, make decisions, and automate the decision making, and be able to have good program control for that, and also supply it with good support when it came with field service to ensure commissioning, startup, maintenance, and some debugging, and reduce any downtime that might affect their production cycle. So what were the results here? The results were really great. we were able to provide that real-time control. We found an analyzer that really the sweet spot was that 10 ppm limit, so we could be really confident with the results there. And as they go, they can continue to evolve and get tighter and have less fudge factor. They did have significant costs. So we went from 36 million gallons being hauled, which takes fuel, affects the environment as well, and cost to get to those other sites to produce it. This saved them nearly $300,000 alone, just in being able to divert when they absolutely needed to and be able to go directly safely to the environment, and obviously avoid those exceedances and reduce and eliminate those permit violations. So really a great way to be able to come in and solve a problem. Here on the left, you will see this is the more modern version of the analyzer in question, where I'll talk about in a little bit more detail. We've got the digestion vessel, the dilution module, the colorimeter, and your chemical feeds. So I'll talk about that here in a little bit. But again, another great story where understanding the customer system and working with them, we were able to provide a great solution with this platform and be able to reduce their cost and impact to the environment. So let's talk a little bit about this platform and its evolution and what we can do these days. So we did introduce this platform in 2017. This is a more simplified version. This doesn't have the complex glass digestion vessel we talked about. This is purely for dissolve. We've got a dilution module and our colorimeter, and then our chemical introduction. On this side here, we can see the next evolution step where we introduced our controller. So now we have our general controller. Hopefully many of you guys are already using this, and girls, for pH, conductivity, dissolved oxygen. We have about 30 parameters that we do outside of the Easy platform with this controller platform. And again, the simplified colorimetric. And now in 2025, we've updated all the colorimetric and all of the digestion modules to this newer platform with the same controller interface, which opens up a lot of capabilities for us I'll talk about here in the next few slides. So when we talk about advancements, if any of you guys have had the older versions or worked or had us consult you on the older Easy platform, we had over 1.3 billion options, I think, somewhere around there. We had a number of analytes, but every analyzer needed to be configured to the range. It needed to be configured to how many channels. Everything was really kind of locked into the specific configuration for each customer's needs that we had determined. Now we've really been able to reduce that considerably with the new platform and some of the modularity that I'll talk about in the next couple slides. We've improved the functional enhancements, again, bringing a menu structure and other things in place that really help make it more user-friendly and more easily able to support, whether it's through our tech support teams and field service. And currently we're up to about 31 parameters within this new platform. We'll be updating others. So we do have alkalinity and other titrations, high-level measurements that we do with some of the other platform in the 4,000 and 5,000, and even use ion selectives. We'll be updating those as well as we move on here through the platform. So let's talk about a few of the enhancements that we did to try to improve the customer experience. We've improved the door hinges. We want to make sure that those last through the life of the instrument. We have a smoke glass that protects the screen here, or all the innards from any ambient light that might cause any UV oxidation, though most of these are installed in temperature-controlled environments inside. I know when we had the first release in the clear glass, I would take a lot of pictures of our installation, and I'd have more pictures of myself than the innards I was trying to get to. So the nice smoke glass makes it very easy to access everything inside. We do have improved labels. So if you look here on the micro pumps, these are all where the reagents are coming in. Your reagents are going to be located below. It's really going to allow you to make sure that there's no cross connections and that everything is easy to follow within the systems. Same going to the improved sample lid and colorimeter, where again, the trajectory from the micro pumps into those vessels to introduce the chemistries is much easier to maintain, and it's much more secure. So the lid, before the colorimeter can move around a little bit, if you guys have used our spectrophotometers in the lab, like Lamy had shared before, you know, a little bit of movement, especially on the sensitive parts per billion analysis, can lead to some variability in the number. So this is much more secured. It's much harder. If you hit some of the tubing, you're not going to move things that's going to cause any variability. We did also include a grab sample feature I'll show on the next slide. And then the other thing being this closed digestion. So before you saw the picture with the glass vessel, a number of connections, we had to have cooling water. Now we can do air cooled, and everything can be done in this pressurized heating chamber where we can break down the material from total complex material to dissolved ones. Here's a part of the grab sample chamber we talked about. This is the side of the Easy Analyzer, as you can see here. Allows you to put a bottle, whether it's a standard where you can validate, which is also really important, especially if the number is higher than you hoped. Then you really want to make sure, is this a real number? Very easy to validate the instrument. Or if you have another suitable sample from another part of the process that fits the range of the analyzer, being able to fill that vessel up and do a grab sample can make things a lot easier and avoid the lab if you don't have a lab technician or a lab instrument available. We always recommend lab instruments for validation standards. We always say it's not a number until you run a standard, then it becomes data. So important things to keep in mind, and this can even be programmed into the system. One of the other things that we did when we designed this with you in mind is that you might change your mind, or maybe you've improved your process. We see this all the time, and in the past we've had to pull the unit off the wall, and customers have had to invest in a different unit. In this new platform setup, we've evolved it and made it so it's more flexible. So on the left side here, we have 1 to 8 channels available on this whole platform. What's really nice is if you start with, back in the day, if you started with 1, you were stuck with 1. If you started with 4, you could certainly eliminate or deactivate some of the channels, but you really couldn't make those changes very readily or easily. This makes it very easy. You can get the different moduplexes or the catch pot setups to fit your need and or your evolving needs. The other thing here was the dilution syringe. So over here, we made a few big improvements. One is that it's modular. So if you get the standard version and you need to go higher, or you started with the dilution version and you're challenged to get to lower numbers, or you become more efficient, you can remove that and go to the lower ranges. So we have several ranges of standard and below. So standard 50%, 25%, those can be interchanged in the past. In syringes, we could go from 10x to 100x dilutions to get to higher ranges, but you were kind of stuck within those ranges. Now we can flexibly go from top to bottom with just a simple service visit and a couple of modular either removals or additions. The other exciting part that we had to challenge the R&D team to is to make sure we can get down to 5x and not just 10, and that really provided a lot more range capability for us. So I know I've talked a little bit already about the closed digestion. The other thing that came in here was the heated colorimeter. The heated colorimeter can be very helpful, to ensure that there's no condensation. If you get condensation on that cell, that can create interferences to the measurement we're trying to take. Also ensures better consistency of the temperature of the sample and ensure that we're getting the most reliable, repeatable data for you. So some really exciting advancements in this platform that make it a lot easier for us who are their subject matter experts, our sellers, and our customers to consume, utilize, and configure. Some of the other add-ons that Amy had touched on as well, we have reagent counters in the new analyzer, so it's easily to see if your reagents are running lower rather than having to inspect all the bottles. Some of the chemistries that we have actually need amber bottles or other colored bottles, so it's very hard to see at times. This gives you a little bit of advanced notice, so you're not scrambling after running out of reagents. You've got remote alert capability. We can actually communicate to the cloud. You can set alarms through email. We also have a lot more digital communication options. So Ethernet IP and Profinet, which we never had before, on top of the typical analog outputs and relays that every unit has. So what does that result in? Less guesswork, more uptime, more reliability, really focus on what matters, which is good quality data to ensure we can help you with your process and give you visibility to what's going on in the ever-changing world that surrounds us here. Talked about how we have 31 parameters. I won't go into detail here, but you can see we have quite a bit. Not all nutrients, right? So we've got a lot of metals. We've got total hardness is probably our #1 seller, and a number of other ones, peroxides, nitrates, silicas at high levels. A lot of different things here, but really what's unique in this platform is the total digested chemistries. You don't see a lot of that out there. And we can do a lot of these total digested metals, which are very important for permit regulations or process control, including the nitrogen and phosphorus that we focused in on today. So really cool, powerful platform here. A lot of people aren't always aware. It's hard to find some of this information. So it's always good to check with us. We're always expanding our tool belts. We're always trying to find different ways to help the problems that people face where maybe traditionally we've had to say, no, we can't help you. Hopefully we can help you tomorrow and today. One other most important thing about this is not just selling you a box, but selling you a working solution. And how do we service and support that as well, or allow or enable you to service it? So again, to kind of consolidate some of these that I've touched on a little bit and Amy's touched on, the familiar SC4500 interface, much easier to navigate through the menu structures, much easier to go through and make changes if needed and dilutions and such. New expanded manual, so we have one for the 1000 and the 2700 series. Really with the menu structures, a lot more detail than our first revisions, a real good improvement. Our field service teams have new certificates of performance and commissioning steps and reports out there. Quite often we'll even have pre-commissioning meetings with you to go over the installation, look at pictures of the install, answer questions so that when we get on site, we can turn these things on, get them running, calibrated, validated, and off and running without a hitch. We do have service upgrades available as well. So we're talking about being able to remove and add those dilution modules. We can add detailed, we have detailed service sheets online that we can share with you that go over what we cover, what we don't, the quarterly visits that I had mentioned, where we're changing out the tubing and doing validations and checks and third-party certification for you. And then one of the things I like to point out, and a lot of what we do is our training, Hach University. We have some great chemists and trainers inside the factory and a lot of ways to help support you from lab to process, not just on the instruments. Our technicians are great at fixing these, but they're not necessarily chemists. And so having this type of training with PowerPoints and such can really be helpful in setting you guys up for a long success and supporting your efforts. We can go over lab chemistries. We can go over instrument operations, the typical things that you need to know when we're not there, how you can help us if lightning does strike, because we know that lightning does. It's a great platform to help people at a higher level. So I just wanted to say thank you for your attention here in this discussion. Thank you, Amy, for your great discussion on phosphorus. Stacy, your introduction, and Brad, connect us again. Thank you for your heavy lifting in this process here. We're happy to answer any questions you might have and really explore this. And just know, again, if we don't get to it here at the call, we'll send you an email if you'd like, responding to the questions we don't get to. Thanks again.
All right, amazing stuff, Mike, Brad, or Mike, sorry, not Brad. Brad, we were thanking, but Mike and Amy, thanks so much. Appreciate this presentation. It's great. It's always great to see the new and exciting stuff that Hach's doing, and it was awesome to have the case study, to see Amy talk to someone kind of that's using everything and get his feedback. That's awesome to see. So audience members, we are going to get into the Q&A here real quick. I just have a couple reminders of a couple things on your screen. Right below where you're seeing me, you can reach out to our presenters directly. Click the little blue circle that's to the bottom right of their photos. You click on that, it'll open an email message, and then you can message them directly if you want to have a question for them or reach out to them that maybe you don't want to ask here. But we are taking questions, so definitely submit them through that Q&A. Q&A should be right below the slides as well. And then off to the right, there is a survey. I'd appreciate you taking a couple of seconds here to respond to that survey for me. We use that information to kind of, help craft future webinars and what we're doing going forward. So thanks so much for that. And so with that, let's get into the Q&A, and let me get everybody up here on screen. And so real quick, let's start with this one. So can you clarify if or how the methods you presented are accepted by the US EPA?
That's a great question. The US EPA, actually, they approve methods, not analyzers. We get asked that a lot, actually. So there could be state and local agencies driving test requirements or methodologies that are more stringent than the US EPA at the federal level. The ones that we specifically talked about today, like phosphorus and nitrogen, the online instruments that are performed in the EZ platform, they conform to standard methods. However, customers typically do not want to report off of their online analyzers. Typically, they're using lab methods with reporting their discrete data in accordance with their permit requirements.
Good stuff. Yeah, thanks, Amy. Let's see. So here's another one. So I need to consider monitoring another nutrient that you that you didn't cover in the presentation, like a nitrate, nitrite. Are you able to monitor those as well?
Yes. No. In some cases, we actually have multiple flavors to solve the problem depending on the range and the application. So that's where we really like to engage customers on site and try to find out what's their real situation, what's the context, to make sure that we have the right box. We don't just sell boxes. We want to be able to make sure we can solve the problem with something that's sustainable. So a lot of laboratory solutions and process analyzers. The Easy platform does have nitrate and nitrite as well as ammonia, some other methods that are available other than the nitrogen phosphorus that we didn't talk about. But again, there might be other ones that we have in our tool belt that might be the better fit for the specific site and budget.
Great, thanks, Mike. So let's see, next one. So if I only need to measure, nitrate or phosphorus for a process control application, is there a lower cost sensor option to monitor those parameters online? For example, a spectral UV vis probe.
I mean, Hach has an entire water quality portfolio with a lot of different options for online nutrient analysis. Nitrate, we have more than one option for that. We do have a UV probe that can measure online nitrate, so that's more in a sensor versus kind of a wall-mounted analyzer. For phosphorus, for a true total online phosphorus analysis or ortho and not a surrogate, we always recommend that you do the actual measurement, which we saw today in the case study and even with the interviewee, that there is great correlation between their lab test and the online. So no surrogates needed there or correlation. And, that method is going to give you the actual results that you need. Phosphorus is one that, there really isn't a great option out there for more of a probe for just the methodology that it requires. Mike, did I miss anything?
I think you're good.
All right, perfect. Yeah, thanks, Amy. Let's see, let's get to a couple more here. So what would drive a facility to monitor orthophosphate versus total phosphate?
That's a great question. We get that all the time. And the magic answer we love to answer with is depends. No, really, orthophosphorus is normally monitored for feed forward or chemical feed. So as your chemical process is changing, your phosphorus loads are changing, that you can dose the right amount of chemical and be efficient and not create more sludge than you needed. But you can also measure it on the feedback. So that's going to let you know, are you feeding enough chemistry to sequester all of the phosphorus and allow it to precipitate out? But the bottom line is that it's a complete process. If you're combining that phosphorus but it's not settling out and you're getting carryover, then that could really affect your permitted limits, which are typically in total phosphorus, not ortho. So giving a TP result or total phosphorus result and breaking down all those phosphate complexes is going to ensure that you're meeting your compliance and that your whole process is working. Sometimes we combine a lot of different things. It could be orthophosphorus, total phosphorus. We prefer you guys actually get the whole suite, but we know we have limited budgets. So that's where working with you to find out what you guys need and what's going to be impactful to the challenges that you're facing is an important part of this process.
Yeah, good stuff. Thanks, Mike. Let's see. So how about this one? So can TKN be accurately monitored online?
So that's another great question. If you guys are familiar with, for a long time in the industry, we would do you'd have to distill a sample and then do an ammonia test to get a total TKN analysis, essentially. Hach had developed and put together a simplified TKN test that you might be familiar in the TNT platform, where we do a total nitrogen and a combined nitrate, nitrite. So if you take your total nitrogen and you subtract that, what's left over is your TKN, which is your organic nitrogen plus your ammonia. We have the same ability to do that with online analysis. So if we talked about that total nitrogen analyzer earlier in this case study, one can then also combine it with a number of our tools for like our Nitritax in the past or our NT3100 now, which gives you an NOx or nitrite nitrate combination measurement. And by doing subtraction in your SCADA DCS, you can have essentially a TKN result every 30 minutes to ensure your process isn't toxifying or that you might be meeting your compliance limits in your discharge. So great question.
Perfect. Yeah. Thanks, Mike. All right. Maybe we can get to a couple more here. So this looks like a good one. So they're asking with tight phosphorus limits, for example, like 0.1 milligrams per liter monthly average or 0.2 milligrams per liter daily max. What alarm set points and escalation steps do you see work best in practice?
Well, I think what we heard from, the chief operator is they're utilizing SCADA 100%. I mean, that plant just has one shift. So they're able to remotely see while they're off site at night on weekends, real-time data, what's going on. So they can make active changes if there is like an influence spike that comes through. So typically, with our online analyzer, even if it's not controlling a chem feed pump, the data that it's producing and updating for, that specific application is like every 30 minutes, et cetera. They're able to kind of put in a high level limit alarm. So if my phosphorus starts to go above X, I'm going to get an alarm or warning, and that's going to alert the plant to make a chem feed adjustment. That's usually kind of the first line of defense. When we talked about wasting rates and things like that, that's more kind of handling the overall total biomass of solids that's within the facility. So, if you're not familiar with biological nutrient removal and added plus chem feed with chemical phosphorus removal, you also have to waste out that phosphorus that's being precipitated out. And if you keep circulating it back through the plant, you can be chasing your tail. So they're also using that for their wasting rates and their return activated sludge throughout the process. But not all plants are created equal, nor permits, nor treatment technologies. And there's a lot of different ways to treat phosphorus. So it really is kind of plant dependent.
Gotcha. Yeah. Thanks, Amy. I did have somebody ask real quick if there's going to be a recording of this presentation, and there will be. You can use the same link you used today to access it on demand. It's usually just a couple hours, could be up to 24, but often by the end of the day, it's available. And then it'll also be on the Water Online website as well. And you'll get an email with a link to it as well when it's ready. Let's see. Let's try to get a couple more in here before we wrap up here. We're almost at the top of the hour. So this one for seasonal industrial phosphorus swings, from like cleaning products, foaming, industrial discharges. How do you use trends to tune wasting rates and ferric chloride dosing without overfeeding chemicals?
Yeah, that's exactly another great question and point that was kind of talked about in the case study, because the one thing about wastewater plants, they have no control over what's being sent to them, yet they have to 100% control what they're discharging into the environment. And, it's a really difficult balance. It's not easy. I recommend anyone, take a tour of a wastewater plant and appreciate what happens when you flush your toilet. The influence and the inputs to that facility, like we said, they were running blind with just literally getting their 24-hour composite grabs out of their influent sample and their effluent sample and seeing how well their process was doing. They were just kind of setting it high at that point and essentially overdosing just to stay under their permit limit. That's what a lot of plants do. They're not really doing any kind of fine tuning or control. They'd rather run it high, but then there's a lot of operational issues, like he mentioned. Ferric chloride specifically is corrosive, and that can actually attack a lot of the mechanical equipment processes and the entire treatment train, secondary clarifiers, pumps, etc. And then it can also foul up the tertiary sand filters, requiring more frequent backwashing, and just a lot of other things that happen when you're not trying to base it off of what's my incoming number. Now, once they went with the online unit, what could they do then when, you're right, you don't necessarily know what's coming at you and when. However, if you're trending that information, you have more reaction time now. So once they went with the online analyzer, he's now able to, you heard him, he's still manually controlling his chem feed pump, but it's off of real-time numbers and not just a 24-hour composite that was, when did I get that spike? Was it diluted in my, 5-liter composite jug that, as we talked, is biologically active? So even though it's at 4 degrees Celsius and kind of, in a holding pattern, is that really what you see? So you could have like a 20, 30 milligram per liter spike, but it's diluted in that composite sample. So I'm hoping that we got across the point that with real-time data and trending, you're going to see what's going on. And even if there is a lag time, if you're doing like feedback control, it's still way better than a 24-hour composite.
I would add too, Amy, that The mechanism is just, if you have milligrams per liter of phosphorus, whether it's orthophos coming in or you're doing back control, and you know the flow rate, then if you have milligrams per liter and you know how many liters per minute, then you can use a mass balance and feed basically on the pounds of phosphorus coming into the system. So that's where your real efficiencies come in when you're removing it, rather than overdosing, creating extra sludge, and some of that other the ramifications that Amy articulated.
Yeah, great stuff. Thanks, Mike. Thanks, Amy. Let's try to squeeze one more in here, even though we're at the top of the hour. So in the TP case study, why did you choose sampling points before and after the tertiary sand filters? And what other locations do you commonly recommend for phosphorus control?
Well, as we saw with the limit, it's very low, so it's a really strict limit. And the sand filters are doing that final polishing. So with the violations that they had, they really wanted to see what was definitely leaving the plant, and they wanted to see before the sand filters so they could see what is that final particulate and reactive phosphorus being dropped out there. Now, you can move further upstream within the process, but we also talked about one shift operation, what would maintenance look like? And when you're dealing with a sample that is a little bit better treated versus kind of raw influent that could have a lot of fats, oils, greases, things like that, it just made sense for the plant.
I'll also add, it's very common in any filtration, right? You have GAC filters for organic reduction. You've got green sand filters for iron reduction. Understanding your efficiency in removal and understanding the loading of that before you get breakthrough is critical. So it's very common that people will apply all kinds of analyzers to look before and after a sand filter like that on whatever you might be looking at and paying attention to.
All right. Well, yeah, thanks again, Mike and Amy. We're going to wrap up here. And so with that, audience members, I just have a couple last second reminders. If you haven't answered that survey over on the right side of your screen, I'd appreciate you taking a couple seconds here to respond to that. And then if you want to reach out to our speakers, click the little blue circles again right below their photos. That'll pop up a new window. You don't have to even stay in here, so you can just keep that open and send them a message at your leisure if you do have a question about what we covered today. And so with that, again, one more time, thank you to Mike, Amy, and Stacy as well for joining me. Appreciate your time here today, and audience members, thank you so much for joining us as well. We appreciate you being here. We hope that you all have a great rest of your day and a great weekend, and we'll see you next time. Bye, everyone.
Thank you, Miles. Thank you, too.
Thank you.
Thanks all.